Now, next up, I'm going to talk a little bit just about some normals, just some normal numbers for you before we get to a ventilator, just so you can recognize normal breathing and normal gas exchange. So let's just start off. We'll talk about a normal respiratory rate, a normal tidal volume. So this would be something like you right now, just quietly breathing, right? We'll also talk about your FiO2. We can combine these two together and come up with a minute ventilation. So we'll talk a little bit about this. And then we can talk about some other values as well. But briefly, let's just say for a nice easy math, you guys breathing are about 10, 12 times a minute. But like I said, for easy math, we'll say 10. So 10 breaths per minute. This is also known as frequency. And so 10 breaths per minute for all of you is about normal. Okay? Now, tidal volume differs on how tall people are. Taller people have a little bit larger tidal volume, but for easy math, we'll say 500 milliliters or 500 cc's, and in a decimal, that's half of a liter, 0.5 liters. So, you know, a little bit over a soda can of a breath each time someone just does a quiet tidal breathing as they're sitting down. Minute ventilation are these two multiplied by each other, right? 10 times 0.5 liters comes up with, most of you are exchanging about 5 liters of gas per minute through your lungs. And that maintains normal homeostasis and gets carbon dioxide at a good level and gets oxygen at a good level. Everywhere here on Earth, where humans are living, our FiO2 is 21%, or as a decimal, 0.21. So we breathe 21% oxygen. And on a ventilator, we can augment this. We can augment in other ways as well. And as people have gone through the escalation of some of these different algorithms, once again, these are the COVID resources that we see, and somebody's gone through nasal cannula and already having problems and they need to be intubated and put on a ventilator, then they're going to need a little bit more FiO2, and we'll talk about that. Okay, so these are some normals. Now let's just talk about a couple other terms you might end up hearing while I'm on some of the math and some of the numbers. Let's talk about an arterial blood gas. Most of you, if we took an ABG from you, you would have a pH of about 7.4. The dissolved amount of carbon dioxide, or P little ACO2, would be about 40. And the amount of dissolved oxygen, or P little AO2, would be about 95. All right, so that would be a normal blood gas. Because we're going to start talking about some of these other numbers a little bit later, right? We can take a look at what we call a PaO2 to FiO2 ratio, and that's where we take this PF ratio and we take our PaO2 from our blood gas, here it's 95 for you, we divide it by the FiO2 as a decimal, and this comes out to be about 450. So all of you have a PF ratio of about 450 right now. Now, if this starts to get below 300 and less than 200 and less than 100, we talk about mild to moderate to severe ARDS. And we'll talk about that later, but at least know it's the PO2 divided by FiO2 as a decimal. The frequency to tidal volume ratio is something that helps us determine, can somebody come off a ventilator? That's much later. The way we calculate this is taking the respiratory rate. Once again, you guys are breathing about 10 times a minute. We divide it by the tidal volume, and we come up with 20. Now, when we get towards thinking about somebody come off a vent, if their F to VT or rapid shallow breathing index is greater than 105, they have a high failure likelihood or a high chance of failure. So these are some of the normals that we're talking about and how to calculate some of the numbers that you'll be hearing throughout the talk.